Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Max Moreau, and unfortunately Phil is not with me today. He had to work late. As I do not have a job anymore, it's very easy for me to do the show on time. Yay! I'm sad now. Alright, so anyway, what we're doing today is we're going to be doing more shooter stuff. I had a request for Spreadfire, and I actually wanted to show a funny video at the beginning of this, and I didn't get time to actually edit it and put it together. I've been really busy. I'm moving in with my mom. I've got a few things going on. I've got projects I'm working on, and I'm still doing my show. Mostly because this is the part of my life, this one show is the only thing that keeps me going, man. I love doing this show. I love you guys, and I'm so thankful that you guys are watching, and I'm glad that you like the show too. So let's look at what we did on the last episode, and so I'm going to go into main screen. I don't have to worry about Phil when I say main screen. And here's what we had going on in our last episode. So if I hit play here, we've got up, down, left, right movement. It's not smooth. It's very jerky, just like good old arcade days. And we can hit Z and we'll fire, and we can blow up an enemy. So that's how far we got last episode, which honestly is pretty respectable work, I'd say. The bullets automatically clean themselves up when they go off the screen, so that's cool. We have basic collision working with that enemy. We have basic flight control. I mean, this is a good start. This is a very good start. I only mentioned spreadshot in the description, but we should probably do spreadshot and maybe do a scrolling example, even though I'm not really sure what I'm going to have for art for that. But yeah, so I kind of want to show bidirectional scrolling and background scrolling and stuff like that. And but I'm not sure if we'll hit that immediately. I'm going to start with Spreadfire because I really should say this for the next episode, honestly, because it makes more sense with the context. But basically, my buddy Eric contacted us on the show and was like, I want Spreadfire, and you probably heard Phil make a small mention of it, but like he actually recorded a video of the request while he was doing it, and it's kind of hilarious. He was a little drunk, and so it was... it's just really entertaining, and I want to actually splice together a video, but I don't have that prepared right now. So first off, there's this new behavior script. I'm going to delete this because I remember we started by deleting this last time on the last non-2D episode, and then I realized that I was on the 2D stuff when I should be not on the 2D stuff. And so we didn't do anything with that script, so I'm just deleting that script for cleanup. Let's do some organization. So I'm going to create a new folder called scripts. And we're going to move our scripts into this folder. I'm going to create a new folder called sounds, and I'm going to put all these little laser sounds and stuff into the sounds folder. These ones came with the Kenny pack that we downloaded, which is awesome. I'm going to put this in scripts. This should be in there. We've got a prefabs folder already. I'm going to put enemy gib in there. And then I'm going to create another folder called what is it called? I'm going to call this materials, and I don't want it inside here. I want it on the outside. It's just basic project organization stuff. I usually like to keep things organized. I don't do it the first time when I'm initially prototyping. I don't organize immediately, but I want to organize as early as possible after that. And I'm going to go ahead and create a new folder called textures. And we're going to put energy gib here in textures. PNG folder, I'm going to rename this what this is actually, Kenny Art. This is from, I think he has an E in his name. I'm going to put the E. This is the guy that does free art on Open Game Art, and we're using it on the show because it's free and it's awesome. And so I'm going to say sprite art. And then finally, I'm going to create another folder called fonts, because his stuff included some fonts, which is cool. Move this back out here. I'm not sure if we're going to actually use them, but I just want them to be available. And yeah, so we've got the player ship to red. Is that actually what we're using for? Yeah. So I pulled this out of the Kenny sprite art. We're kind of move stuff out of it and cannibalize it as we go. And hopefully I have comments here. I don't have someone on comments right now, so let's see. So what are we going to start with? So first I want to show all it takes to actually get spreadshot going. I'm just going to do it. Because this will be short. If we wanted our bullets to not just be straightforward up and down, we can do a spreadshot. And I'm gonna actually make this a power up ultimately, but let's actually implement it first so that people understand what we're doing. So right now we've got our player, and our player has a shoot script, and the shoot script, all it does is when you're holding the fire button down, it instantiates the bullets, and at no rate. Wait, really? I thought we had some sort of limit to how fast he's responding. Is that not the case? Huh. Bullet movement. I thought for sure we had a delay on this. What happened? Am I hallucinating? Okay, well, I'm going to put a delay on it. I thought we had adjusted the delay to a certain amount, and then it got it so that the bullets looked exactly right, and... Huh. Player mode. We're not doing anything in here, right? No? This is the only place where we're creating things. Okay. Anyway, let's add that. So right now we're just firing a bullet every frame when we're holding down the shoot button. Let's make it so that there's actually a delay on this. So public float shot delay equals 0. Let's do 0.2 f to start with. I swear we had this before. And all we're going to do is if we get button fire 1, okay, so let's do public, let's make a private, bool ready to shoot equals false. Actually, let's default this to true. So if input dot get button fire 1 and so this means we want both of these things ready to shoot, then we instantiate our bullet, and then we're going to set ready to shoot equals false, and I'm going to create a another thing here called we're going to create a function void delay. Actually, let's do reset ready to shoot. That's what we'll call it. And we're just going to call invoke reset ready to shoot. There's a bunch of different ways we could have done this. This is just one of the myriad ways, but this is an easy way to do a timer. Invoke can take a time parameter, and so we'll do ready to we'll do shot delay here. Shot delay. And so what will happen here is, so we fire, it instantiates, we fire because it says it's ready to shoot, it instantiates the thing, it says that we're not ready to shoot anymore, and then in reset ready to shoot, we're going to set ready to shoot equals true. Yeah, I guess we didn't set a bullet rate. That's weird. I swear we did. I guess it was just, it happened to look perfect anyway. Even though it really doesn't seem like... Oh, that's what we did. We set the speed of the bullets, and it made them look right. Okay. So we didn't set a shot rate because we didn't need to. Now I remember. I'm going to go ahead and implement this anyway because it'll provide us a way... I'm actually going to set the shot delay to... Well, no, I want there to be a delay in the default, so let's do 0.2, like I said. And so what this will do now is this will make it so that you can't fire faster than a certain rate. This will be important later when we're doing more complex shot patterns, and there's a problem with some invalid arguments. So Oh yeah, we need to actually give this the name ready to shoot. So if we hit save here, so that's what I was forgetting. It was just we just assumed one frame every shot, and then we don't use the shot delay. So now we have a shot delay, and so now if I hit play and hold down the fire button, you'll see that there's a delay in our shots. And this is another way we can do power-up stuff too. We can make it so that, like, as your power increases, the delay goes down. But this will allow us a little bit more flexibility in our shot script. I'm going to turn it back down to 0 just because we tweaked the movement rate so that in a frame it moves about as far as it needs to have things basically one right after the other. And I think that looks pretty good for right now. We might want to put a little bit of a delay in later, but we'll definitely need it for other power-ups and different types of effects. Like if we have some sort of bomb-type shots or something, and we don't want those shooting once every frame. We want those shooting with a delay. So, sorry I got confused there, but as to what we had done last time. So if we wanted to do a spread shot with our current bullets, it's very easy to set this up. So right now we've got shoot on the player. It doesn't have to be directly attached to the player. We can create an empty game object and attach it to the player. And we could make the shot be on here. So if I so the position on this game object is 0, 0, 0 right now, and that's relative to the player. So it's right on where the player is. And I'm going to call this I'm going to call it, what should I call it? Let's call it barrel, like as in a gun barrel. That's really not a good name for it. Hardpoint might be a better name, but so I'm going to remove the component from here. So if we hit play now, it's not going to shoot anymore. And then I'm going to attach the component here. So we're going to put shoot back on here. Whoops. Okay, I put it in the right place. And we're going to set the shot delay to 0. And we're going to hit play, and it should work exactly the same way as it did before. And it doesn't, because we didn't assign a reference here. No, our rotation may be wrong too. So let's assign a reference, player laser, and hit play, and hit Z, and we're shooting again. So now, if we want this to be a spread shot, all we have to do is basically duplicate this barrel a couple times, and we could have just a left barrel, right barrel, or barrel 1, 2, 3, etc. And these will all be shooting as well. And the way we set up our bullet movement is the bullet movement takes its transform.forward and moves based on that. So as long as we spawn it with the appropriate angle, it will work. And our shot stuff automatically spawns with the oh wait, no it doesn't. It responds with the okay, we're gonna have to fix this. It currently responds with the bullet transform rotation in the script, when we actually should be spawning it with something else based on our current transform position. So if I rotate the left barrel right now, it's not going to actually work, but I'm going to do it anyway. We're going to rotate this thing along the... So these aren't facing forward. So the player, if we look at his facing in 3D mode, he's facing out. And so we're going to want these to actually face upwards so that the bullets face upwards. Right now they're just spawning with the bullet's orientation, which is in the prefab here. And so if we go into player laser and change the rotation here, so if we rotate it along one of these other axes and hit play, and when we fire, you'll see that it fires in a, well, it's not going to look any different if it's the wrong axis. Hold on. Let's try 20 here and hit play. That still didn't work. I think I'm running into some gimbal lock problems. Okay, I'm not going to show you the non-working example. Let's just make this actually work. So instead of using bullet.transform.rotation, we're going to use transform.rotation. So I'm going to save this, and we're going to hit play, and we're not going to see our bullets again. We're going to hit Z, and it's not going to work. It's actually working, it's just they're going into the scene again. Remember we had this problem last time? So when we fire, we go into the scene. Because now they're using whatever the Z, which is the blue arrow, is, however it comes out. So we want to orient this so that the Z is in the proper location. So I'm going to take our main barrel here, and I'm going to rotate it. If you hold down the Command key or the Control key if you're on Windows, you can rotate in nice little chunks. And so now, when we go back, you'll see that the blue is facing upwards. And if we hit play again, you'll see that I'm shooting upwards, but we're also still shooting into the seam because we've got the other two barrels there. So someone already answered someone else's question, so that's good. All right, so what we're going to do now is we can rotate these things the same way. So 270, so we're going to do 270 here. We're going to do 270 here. 70. And then the left barrel and right barrel, I'm just going to rotate a little bit differently. I'm going to move these so that there's some meaningful rotation. So you can see that all the rotation stuff kind of changed on me. And the reason is because Unity's desperately trying to avoid gimbal lock. We've already asked it to do something horrible, which is look straight up. And so we basically have to change it to 90, negative 90 here, and then we adjust our rotation appropriately here. So 270 would be straight up, and so if we go back to the view so we can see the arrow coming out, and so 300 is slightly more to the right. So let's do 300, so that's 30 degrees right, and then let's do left barrel, same deal as 90, negative 90, is that the one way we had it? Yep. And we'll do 30 degrees less, so it'll be, man, math is hard, 240. So now if we hit play and hit shoot, we have a spread shot. So now we have a little example of how to get multiple bullets in there. So let's actually, yeah, I think a power-up system is a good thing to play around with here. We're going to need to put more level stuff in at some point too, but since we're already working on bullet stuff, might as well see about making a power-up system for this. So, actually, another thing right now is our enemy right now, I think, will die if it hits anything. So, like, we can smash into it. Oh, wait, we can't smash into it with our player. Why can't we? Probably because I didn't set it up the way I thought I set it up. So, how are we? So, gib on trigger enter. So, the problem here is the player doesn't have a rigid body. Doesn't the enemy? Yeah, and since we're moving the player around, it needs to know that he's moving, so we need to give him a rigid body. Oh, we're playing. He just fell out of the world there because we had gravity. So we're not playing anymore. I'm going to hit physics, rigid body on the player, and we're going to set it to is kinematic. That'll make it so that gravity doesn't affect it. We actually don't even need to uncheck gravity. If you're kinematic, you won't be affected by it anyway because you're manually moving stuff. But I like to uncheck it just to be consistent. And so now if we actually run into the enemy, it still didn't work, because the player doesn't have a collider either. So we're going to give the player a box collider. Again, we're using the non-2D physics stuff because right now I don't trust the 2D physics stuff. And we're just going to keep the collider really big for right at the moment. And we can actually call it a trigger too. It doesn't matter really in this case, but we're going to be doing most of our stuff with trigger logic because we're not going to have physical reactions. Like when you bump a ship, it's not going to bump a ship and have it like apply a force. We're just going to have trigger based. This is going to be like a standard old school top-down shooter. So now I can run into the guy and he'll die, which is actually not what we want. We actually want to run into the guy and die ourselves. And so I'm sorry, Ryan, that YouTube is being crappy. It happens a lot. I have to hit refresh a lot too, just to make sure that I'm not behind on the comments. So let's go ahead and fix that. So what we have right now, the player is not tagged as anything. The enemy is not tagged as anything, and we can use tags to help to differentiate what's going to hit what and what's going to do what, or we could use layers to do it. And so do I want to do layers or do I want to do tags? Let's do layers. So we're going to add a layer. I'm going to call it enemies. Actually, I'm going to make a player layer. That rhymes. I'm going to make an enemies. I'm going to create a player player bullets and enemy bullets. And so I'm going to mark the player as a player. I'm going to mark the enemy as an enemy. Whoops, that's not actually the player I wanted. Tagged him as a player as well. It's not a bad thing to have tags as well. I'm going to just leave them untagged for now so I don't confuse people. We're working with layers right now. So player as a layer. So do you want to set the player for all child objects as well? Sure. Yeah, let's do that. And on the enemy, we're going to do the same thing. Enemies. Yeah, sure, change the children. And on so on our player laser, we're going to set this layer to player bullets. Yes, change children. So now we're going to go into project settings and go to physics, and we have this this collision matrix here. I'm going to actually close the. I'll leave this open for right now. So this represents what collides with what. Actually, I'm going to close these for right now. We can open these later just by going to the window menu for animator and animation, respectively. We're not doing it right now, so I'm just going to leave this open so that we can see everything. So this represents what collides with what. We've done this on the show a few times, but not on this episode, so it's a good time to redo this stuff. So we want player bullets to we don't care about player bullets hitting enemy bullets. Because most of the time when I'm talking about a bullet, I'm talking about something that can't be stopped. If we have like missiles or something that enemies shoot later, we may want to actually treat them. We'll either mark them as enemies or we'll create a new class called enemy destroyable shots or enemy missiles or something. But for right now, we're going to do player bullets. So player bullets don't hit enemy bullets. Player bullets shouldn't hit their own thing. Player bullets should definitely hit enemies. They should not hit the player. And I'm going to make them not hit anything else, honestly. So they will only hit enemies. Enemy bullets, we're going to have them only hit the player. Actually, I'm going to leave default, just so that way we can have the walls block things. We'll have walls in there under default. And so we want enemy bullets to hit the player. Stop. Okay. And let's see, what else do we need? Sorry about the phone call there, folks. So enemies should hit the player, and they shouldn't hit other enemies. And player bullets already hit enemies down here. So remember, you kind of read across and you read down as well. And as you add things, it just adds them to the left and the top on here. And so it's kind of complex when you look at it, but it's just literally like, look at what's going on. So enemies don't hit enemies. Enemies do hit the player. Player bullets hit the enemies, etc., etc., etc. And the player should hit, I'm going to have them hit default. I'm going to have enemies hit default as well. Player's going to not hit anything else other than enemies and enemy bullets. And I don't really care about the other layers here. I'm just going to leave those on their default values because we're probably not going to be using them anyway. So now when we hit play, we can still hit the enemy because I told you we can hit I told it here that we can hit the enemy. And but we're not dying from it. The enemy's dying, and actually I'm probably going to keep that because I kind of like it when the enemies take damage when you hit them as well as yourself. Because it's easier to do from a trigger standpoint. So let's also make it so that we can lose a life now. Let's go ahead and create a little bit more game logic in here. So right now we've got player movement. I'm separating these out again. We could have them as a monolithic script that just handles all the player stuff, and I might move to that later if I feel like it's more appropriate. I'm going to go component-based on this one just so that we have more flexibility in what we do with the game later. So I'm going to create a new script. Actually, I don't think I have to create a new script. So we have gib on trigger, right? This is why we do a component-based. Let's put it on the player. And so now, if we hit play and we run into our enemy, we both die. We don't have a little explosion effect for our player. What I'm going to do is we've got our energy gib here. I'm going to create a red one for our player for when he dies. So I'm going to copy this over to, as I said, we're kind of pilfering from this to here. I'm going to call this red energy gib. I'm going to change this one to blue energy gib. If you rename things in Unity, it automatically keeps everything up to speed. So if I go into our sprite gib here, you'll see that it's using the blue energy gib, even though we've changed the name on it. Unity's really good at tracking this stuff. And so we're going to change this to a texture, just like we did last time, so that we can make our explosion thing. And I'm going to do true color, filter, point filtering, hit apply. And then I'm going to create, this is blue sprite gib. I'm going to create a new one called red sprite gib. And all I'm going to do is I'm going to change the particle texture. Now there's another way we could do this. We could do it by tinting, but these textures haven't been set up for that. If we had set them up so that they were just white in the areas that we wanted color, we could get away with that. But this one also has a white component, so we kind of can't get away with it, if that makes any sense. So I'm going to put this now. So we have a red sprite gib. I'm going to go into our prefabs. And we've got enemy gib. I'm going to duplicate this. We're going to create a player gib. And all we're going to change is, instead of using the blue sprite gib, we're going to go into our materials and drag in red sprite gib onto player gib. So now when we go down here, it shows red sprite gib. And on our player, we've got gib on trigger. We put our player gib here. And when we hit play, we should see that when we hit, we both die, and we both have our individually colored explosions. So we have we're getting on the workings of a vertical scrolling shooter here. We've got an extremely overpowered, powered up laser right now, and it's kind of cool. It spreads out, and we've got our player can get killed. They shouldn't be killed by their own bullets. Like if we had set up the collision matrix wrong, like here's something that could happen to you. Maybe you hadn't set it up so that you don't collide with your own bullets. So player bullets might collide with the player. So where's player? So player bullets. If we had this checked and we hit play and we hit shoot, we'll kill ourselves immediately. It's because our bullets hit ourselves. And so this is how we're keeping everything in check, is using the physics manager. There's another way we could do this. We could, in the script, check for tags, and we may or may not have to switch to that. I kind of want to avoid that. I kind of want to keep this one organized for layers. But there's nothing wrong with using tags. It gives you another additional option if you need some more complexity than just what's here. But you have to intentionally script for it. If you just handle all triggers and make sure that the only triggers that fire are the ones that you want, then you don't have to handle anything in the script. So I'm going to go ahead and save scene, save project, so that we don't lose any work while we've been working here. And what are we going to do next? So right now, if you die, it's over. I'm going to leave that for right now. Maybe I won't. I might lie about that. So let's make it so that there's a game over, a very, very basic game over. So what I'm going to do is we're going to create a new script. I'm going to call it C# script. I'm going to call it game over on trigger. I'm going to double click it and we're going to start editing. So I'm going to create a public. Actually, I'm not going to create anything. I'm going to create a private. I'm just going to say game over. No, just game. Oh, private. Okay, we need to give it a type. Private bool game over. And we're going to set it to false to start. Whoops. And then what we're going to do for now is we're going to void on trigger enter. Yeah. So on trigger enter, we're going to say actually, I'm going to make it game over on destroy. We're not going to use it on the trigger. So if the player gets destroyed, this will call. This teaches another function at least, and so on destroy gets called anytime an object gets destroyed for whatever reason. This may cause certain problems as we're changing levels and stuff. So keep that in mind. I'll try and point out these. We're going to be reorganizing this stuff as we go along, as usual. So on destroy, we're going to set game over equals true, and then I'm going to create. Well, I'm not creating a function. I'm going to type in on GUI. This gets called for drawing GUI elements onto the camera. This is really, it's not going to provide a really good visual result, but we just want to have a little bit of user feedback for right now. And so all I'm going to do is I'm going to do GUI layout dot label dot and then all we have to do is give it the text that we want to say here. So game over. So let's just start with this. So if we hit save now, and I attach, I'm going to rename this to what we called it, which is on destroy, and we put this on our player. So now when our player gets destroyed, actually it's not going to work right just yet. So this is game over in the corner there. That's actually not what I wanted. I actually only want it to say, oh, let's double click this one more time, because I had changed the name. Mono Develop had to reorganize this stuff. So we actually don't only want to do this if it's currently game over. So if game over, say game over. So if we hit save and hit play, we now see no text on the screen, and we ram into the enemy here and die. Nothing happened. Huh. So game over on destroy. On destroy. Did I spell it right? It looks like it. I'm saying game over equal to true. Alright, so let's make sure I'm using the right thing. Unity on destroy. So yep, it's called on destroy. It's attached to the player. Alright, let's make a debug log. It should be game over. So if I hit save here and hit play and blow up my ship, it says it should be game over. Interesting. And yet it does not say game over in the corner. Oh. Yeah. Okay. I know what happened. Yeah, this is not going to work the way I've written it. So it did work. The problem is the on GUI thing here is in this script, and we have just literally destroyed the script. And so even if game over is true, we won't see it anymore. So we're going to have to create a separate script to actually handle the showing of the state of game over and stuff. So I'm going to create a new script called Game Manager. And I'm going to double click it. And I'm just going to paste in game over. I'm going to paste in on GUI here. Just delete all this stuff for now. And what else are we going to do? So I actually don't want this to be private. In this case, I want it to be public. because we're going to have to access this from other scripts now. And what we're going to do on game over on destroy is we're going to set this thing to game over to true from the other script. Now there's a few different ways we can do this. Probably the most appropriate would be the singleton method. I actually don't have my singleton reference here right now, so I'm going to skip it again. And instead I'm going to use a tag, find the game object by the tag, and then do something with it. So I'm going to create a new game object. I'm going to create an empty game object. It's only in the game objects menu. It's not in this create menu for some reason. And we're going to just call this game manager. And I like to put a $ in front of things like this so that they show up on the top, so that they're easy to access for changing global variables and stuff. This is not going to have much to change in it just yet. And we're going to attach our game manager script to it. And I'm going to go into the inspector and add a tag called game manager. And then if we go back into the game manager, pull down the menu to game manager, this thing's now properly tagged as a game manager. So now on game over on destroy, we don't care about on GUI or whether it's game over or not anymore. And on destroy, we're going to set game over true on the game manager. So we're going to get game manager game manager equals game object dot get find game object with tag game manager, and then we're going to set game manager dot game over equals true. So what this is doing is anything that has this on it, which is just going to be our player, when he gets destroyed, it finds the game manager, it tells it game over is true now. So we hit play. Oh, I messed up something. So can't convert to game object. Okay, so I forgot to actually get the script too. So this is just the game object. We actually want to do dot get component game manager. So if I hit save again, that should fix that script. If we hit play, I ram this guy, game over, shows it in the corner. We've got these little goodbye messages. We had this when we were debugging before. I'm going to actually get rid of them now because they're just going to confuse us. So hit save. So get to hit play again. Game over. Yay. Now in our game manager, I'm going to do one more thing here. We're going to create our update thing here again. So void update. This gets called every frame. And we're going to check if game over, then if input dot get key, I'm going to use get key directly on this one, get key down. We're going to use key code dot enter, keypad enter, actually return is the one I want. So if we hit return and we're in the game over state, we're going to application.load level loaded application.loaded level. What this does is it resets whatever level we're on. This is not going to be your final logic because we're not going to want to reset right on the level that we got to necessarily. There's also going to be, we're not going to want to have game over immediately when we die either. This is just temporarily as we work so that we have more of the game working. And maybe we do want game over if we die, as we die for certain types of games, like Super Hexagon's a perfect example. When you die in that game, you're dead. There's one life. Cannonball, one life. But we're probably going to have multiple lives. We want to have a little bit more of the old like Raiden/arcade feel. And so, so this will work for our purposes for now, though. So if I hit play again, and I run into this guy, and I hit enter, we're back to where we started, and we can continue playing. So I'm going to do one last change to the script before we move on to something else. All right, so this is the problem with doing onDestroy. OnDestroy gets called by Unity as well when you load levels and change things. And so sometimes you might get null reference exceptions here. I'll show you how to fix this in a bit. but I'm not going to worry about it for right now. It's not going to hurt you in the short term. I'm going to put game over, press enter, or press return to reset. Now we've prompted the player. And so now you know that when it's game over, you can hit the return key to reset. Could probably put a you win at this point when you shoot this one dude, but we're going to have a lot more than one dude later. So what are we doing? So we could add scrolling, we could add power-ups, we could change some of the way the hit stuff works. So one of the changes I'm going to make right now is we have a collider on here for the player, and it currently is the same width as the player. So like if we just barely nick this, we're going to die. And we have the same for the enemy. The enemy has a big collider around it. Now, we're entering into game design theory here now. I really like bullet hell shooters, and I really like to have a lot of bullets on the screen, and I like to have it where it feels good when you get through a horrible situation. So I actually like really, really small colliders for the player. I like big colliders for the enemies, small colliders for the player. And the reason for this is it allows us to dodge more effectively. So what I am going to do is I'm going to change the player's hitbox so that it is considerably smaller. So right now the hitbox has these dimensions. I'm going to make this 0.1, 0.1, and 0.1. And if we look at the player ship, oh, Kenny, you've outdone yourself. You'll notice that he has this little cockpit in there. So I think he's played these games before too. It's good to have a little visual indicator on your ship that's part of the art that shows where the center of the ship is, especially if you're using a smaller hitbox area. And this allows you to actually make the hitbox as small as possible and make it so the player feels like they're not getting cheated when they get hit. So if I hit play now, you'll see that we can actually skirt right up next to the enemy without dying. And it's totally a situation where we would die under normal circumstances. If you're playing Gradius, you're going to get hit in this, unless it's Gradius 5. So, but if you get a direct hit on where you are and the enemy, you die. And I like this for setting up for what we're going to be doing with bullet patterns and enemies. So, what should we do next? Let's create a little AI for our enemy. And these guys are just going to be the little fodder enemies that you run into right now. We're not doing any boss stuff or anything fancy yet. I'm planning on doing quite a few episodes. Well, not. We'll see how many episodes that we want to do. But I want to actually build this into a really cool little vertical scrolling shooter. So let's create an enemy AI. I'm going to create a C# script called Fodder AI. This is going to be for our really stupid little ships. And we're going to start with the most basic AI possible. And then we might make a fancier one in a bit here. So all this one is going to do is just... we already have a bullet movement script that we could use actually as regular movement. This is honestly just move forward. We really shouldn't even be calling it bullet movement. But... yeah, I'm going to actually rename this at this point. We're going to call this Move Forward. I'm going to save it. And I'm going to change bullet movement here to be called Move Forward. And I'm actually not going to create anything in the fodder AI just yet. So if we want just a really basic enemy, we can actually just attach Move Forward to our enemy. And our enemy right now is already pointed in the proper direction, because we did that on the last episode, even though we really didn't need to. And so if we hit play on this, it should start moving forward at a slow rate and eventually hit us. So this is the most basic AI you can make in a shooter. This is the move forward AI. It's not particularly interesting. It's really easy to deal with. and all it does is it has a speed, and you just bring them in on the screen, and they move forward. I'm going to create, for the fodder AI, I want to do one of our classic sine wave AIs. So the enemy is going to move left and right, and they're going to move forward. And so, in kind of a sine wave configuration. And I'm debating on how I want to actually do this. I'm going to do it the mathematical way, because I want people to understand why they call it sine movement, though I reserve the right to change how we do this later, as usual. So I'm going to create a public float speed. So this is the speed that they move forward. I'm going to make a public float sine amplitude, and a public float sine frequency. And let's give these appropriate default values. So I'm going to do 1.0f, and I'm going to do 1.0f, and I'm going to do 1.0f. These will be functional enough for what we're doing. So I'm going to hit save. And so what we're going to do, I'm also going to create a private variable called private float time. And so over time, we're going to adjust the position of these things based on the sine amplitude and frequency. So we already want it to move forward, so I'm just going to grab the move forward stuff here first and just paste it in so that we have something to look at. So all this does is it moves the position by transform.forward and times the speed times time.delta time. So we additionally want to make the position move left and right. And so I'm going to do the move forward stuff first. So we're just going to leave that as is. So this moves enemy forward. And then we're going to do adjust horizontal position by sine wave. So what we're going to do here is we're going to do a simple mathf sine function to adjust our transformed position a little bit. So we're going to set transform dot. I'm going to create a new. Actually, I'm going to create a new vector3. Vector3 new position equals transform dot position. And then new position dot x plus equals. No, this is not how we're going to want to do this. I feel like I'm already coding myself into a corner here. Let me think about this for just a moment. So we want to adjust the current x by the sine time, but we don't want it to iterate into the next. We don't want it to adjust anything else. And we don't want it to iterate to the next position. This may not be the best way to set this up. So I'm going to create a new private float offset. Actually, I know what I want to do. Let's not do this. Let's see what we can do with this. All right, so let's do new position dot x equals okay, we are going to have to create another variable. private float float horizontal offset equals 0.0f. So what we're going to do is let's set the horizontal offset to what it should be first. I'm just going to comment these out for right now so that MonoDevelop doesn't get unhappy with me and save. And so we're going to set horizontal offset equals mathf.sine, and we're going to do time, and we're going to, so the amplitude and the frequency, so time times sine frequency. I'm just working this out right now. We'll see if this actually works. Time times sine frequency, and then times sine amplitude. So this should result in the offset that we want for our position. And so now we're going to actually offset our position by this. And actually, I don't want to do it by new position.x. We're going to actually do another thing like we did up here with vector math. So we're going to do transform.position plus equals. This still doesn't solve our problem. I'm just going to do this and see what happens. This is not going to work right. Bear with me. This is simple stuff, and I feel like I'm overthinking it. If Phil was here, dang you, Phil. I wish you were here. I love you, Phil. So transfer.position plus equals horizontal offset. I know a way we can do this with the horizontal offset, although this seems really overthought at this point. So plus equals horizontal offset times transform dot right. And I'm not going to use delta time on this because we're kind of already have time in the equation here, even though it's not specifically delta time. Well, it is. You'll see how it is in a second here. So the other thing we need to do is we need to make sure that we actually increase our time variable. So time plus equals time dot delta time. We could just use time elapsed or something else, and that would make it so that all the enemies will have the exact same position sign-wise, but I wanted to make it so that they can actually come out progressively if we wanted to, so that they have kind of an S-curve to it. So let's see what this does for right now. This is not going to be exactly what we want. So I'm going to go to the enemy one. I'm going to remove the move forward script, and I'm going to put in, what is it called? Fodder AI on this guy. So if we hit play, there he goes, off into Neverland. So the problem here is he's moving. What I was trying to do is I'm trying to move him, offset him from his position. The problem is transform.position is actually being changed here. And we don't actually want it to be in that changed state on the next frame for this to work properly. And so I'm going to do something here. This is going to be messy for right now, but it will work. So instead of just moving the enemy forward, we're going to remove offset from enemy. So we have our horizontal offset from the last time, so we're just going to do transform.position. This is not the best way to do this, and we'll get this fixed up in the next episode, I'm sure. We might even do it tonight. So transform.position minus equals horizontal offset times transform.right. So now we're removing that offset before we change the position, and then we're creating a new offset, and then we're moving it out from that offset. So if I save this, this should actually do more what we actually want. So if we hit play now, there's our enemy, and it's following a sine wave. And right now the amplitude is 1, so it will move one whole unit left and right, and the offset is the frequency is 1, so it takes 1 second to go through the whole thing. So 1001, 1002. That seems slower for some reason. Huh. So what are we actually doing here? We're doing 1 degree per second. Oh, okay. So just putting time in, which means these are in. So time times sine frequency. So let's times 360. 360. Actually, this uses radians, so we don't want to do times 360. We want to do times. So we want 1 second to represent one full iteration, and that way our frequency will actually matter. Mathf.sine uses radians, which means we need 2 pi to do that, multiplied in as well. So sine frequency times 2 times, I think pi mathf dot pi. So if we hit save on this, we're going to hit play again, doing some trig here. 1001, 1002, 1003, 1004, 1005. Yep, that's looking right. So now our frequency actually is in full rotations per second, and we're not rotating something, we're moving it left and right, but it's the same type of function. If you look at the sine function, let's look at sine trigonometry. So what sine does, if you don't remember your high school classes, is it represents on a circle. So the sine is the vertical component of a circle based on theta degrees. And so what we're feeding in for theta right now is a time variable. So this basically is just as a number that goes to 1 and then goes to -1. And it will do that over the course of 1 second based on the math that we've given it here. And we could set it up as an animation that only moves on the x-axis, though I'm doing this kind of as an AI thing because I want to do some fancier AI than this. Honestly, we could do this as an animation, and that would be a better way of doing it. I just wanted to get into the habit of doing some script for the AI for right now. There's a million ways to do things in code, and there's a million things to do things outside of code in Unity. And so I try to cover a lot of different methods of doing things, and just because the more options you have, the more you'll be able to do in the future, because there's certain things that fit better for other things. As I said, Dan Tower, his idea is actually a good idea and would totally work, but we're just doing script stuff right now because that's what I decided to do for this. So we have an enemy. It moves based on a sine wave. I'm going to make the sine frequency a little bit smaller, so 0.05, and I'm going to make the amplitude bigger just so that you can see what happens. So if we make the amplitude larger, you'll see he'll move more to the left and the right, and the frequency smaller means it now takes 2 seconds for him to do so. And so you can tweak these values however you want. I'm actually going to make him do a tight little sine wave, so he's just going to move half a unit left and right. And I'm going to make them move just slightly faster. Alright, so now we have enemies that kind of move. There's no represent exception. Remember, this is coming from our destroy thing. It's because we're destroying at the end. We'll clean this up on the next episode. So it's 9:30. I'm going to go ahead and do one more thing. Let's just create a real quick spawning script for enemies. So I'm going to create a ship spawner. Actually, I'm just going to create a spawn objects script. This way it'll be used in a generic fashion, and we can use it for whatever we need, whether it's an enemy or a bullet or whatever. So I'm going to create a public game object to spawn, public float spawn rate, spawn delay, and we're just going to have this repeat based on the spawn delay. So I'm going to create, I'm going to set it to equals to 1.0f we're going to set the object spawn. That we can't set a good default for that anyway, so I'll just leave that blank. And all we're going to do is in start, I'm going to invoke spawn, which we haven't written yet, and spawn delay. And then we're going to create a spawn function. I'm just hijacking this code and getting rid of this descriptor because it doesn't mean anything anymore. And we're going to say invoke spawn delay. We're just going to copy and paste this again and actually do the spawning logic. So object, so instantiate transform.position. Oh wait, no, object original. So object spawn to spawn transform.position, and I'm going to use the orientation of the spawner. So transform.rotation. Hit save. And the reason we do it this way is this means we could do invoke repeating. That's another way we could do this. But if we do it this way and actually manually invoke at the end of the function, it means that if we tweak the values, the tweaks will still work. They'll pick up on the next spawn. So it's useful from a debugging and tweaking standpoint. So I'm going to go ahead and put this onto a game object. I'm going to create a new empty game object called enemy spawner. And we're going to put this somewhere above the screen. I'm just going to put it, move it up to about 10 units. So that should be off the screen. I'm going to put spawn objects onto it. We're going to create a prefab out of our enemy. We're going to drag him in here. So now we have a prefab. I'm going to delete the one that we have in the scene. We're going to now go into our enemy spawner, put an enemy in here, and if we hit play, we should... Oh, this is probably not going to work. So it's going to spawn things, but right now it's spawning them with the wrong orientation. So they're all flying out into the sunset here, and we're never going to see them hit the screen because they're on the wrong plane. And the reason it's doing that is because I didn't orient the enemy spawner appropriately for what we're doing. So I want to actually rotate this thing into a good position for us. So I'm going to rotate it around this way first, and then around this way. And in theory, that should be right. So I wanted to make sure that the Y stays forward on this. So right now our player doesn't have a good orientation for what he's doing, but the barrels do. The object Y we want to be pointing towards the screen because Z is more useful in the quaternion functions to work with, and it means that we can just take the rotation as is. So now if we wait here, we should start to see enemies float into the screen. There we go. We've got our first enemies here, and we can start killing them. And these guys will just continue to spawn forever. And our enemy gibs aren't being cleaned up yet. I'm not going to bother fixing that on tonight's episode. We'll fix that tomorrow. And if you hit the enemies, you'll explode and die. So that about wraps things up. I'm going to hit refresh and see if there's any new... Nope, no new stuff. So I'm going to go ahead and start wrapping up the show. Actually, I'm going to do one more thing before we end. So on just a moment ago, like an hour and a half ago, I set up a video for setting up Perforce version control on a server. It was kind of complex. I hope that people can actually follow it to a certain extent. I will totally help people if you want to set something up like this. But part of the thing I want to get people into is actually using version control, and I'm going to be using Perforce on the show because I think it's a good program. There's a free tier available up to 20 users. And so I'm actually going to check this into Perforce. We're gonna actually make a repository real quick and check it in. So first I'm going to go into P4admin because we haven't created a repository, a depot for this yet. And I'm going to use the server I set up on the previous episode. So P4admin, we're going to go into depots. I'm going to create file new depot, and we're going to call this what are we going to call this shooter? 2D shooter. And I'm going to create a local depot, hit OK. And I know this is a surprise for people, and I know that you're probably not going to be used to this, but as I said, I just want to acclimate you guys to this process. So what we're going to be doing here is putting the stuff in version control. So we'll be able to go back and see what we've done and change things, and if we have problems, we can roll things back. It provides us protection. So don't try to understand this stuff, but don't sweat it if you don't understand it yet. It's going to make more sense as we do more with it. So now I'm going to open up P4V, which is the main Perforce client. And this is the only thing that we're going to be working with most of the time on here. So I'm going to actually save this project, save project, quit Unity. And we're just going to work on Perforce for just a moment. So I'm going to hit OK on here. And I'm going to switch to the Max workspace. Actually, I'm going to edit this so it doesn't require a host name, which I'll explain that at a later time. But so now we have a workspace, and I need to edit the workspace to have our new depot that we just made. So I'm just going to copy this, paste it down here, type in 2D shooter, and paste that into the other entries here, and hit OK. And it doesn't matter what I click here because we don't have anything in there. So now if we go to the depot, we'll see 2D shooter is empty. Hat switch test has the little temp thing that I put in there for a test. We're probably going to remove that soon, so just ignore that. That's from when I actually set up the depot. So so now where I have these files pointed locally is in hat switch Perforce. And so, oh wait. Okay, so I actually need to change one more thing, sorry. So I actually don't want this mapped directly to the home directory. I'm going to actually map it to 2D shooter. So, okay. So, don't update, that's fine. So now I'm going to create a folder called 2D shooter, and I'm going to drag in our project files from today. Just going to copy them, go into where I've got the hat switch Perforce, go into 2D shooter, hit paste, and then finally I'm going to go into my workspace, 2D shooter. I'm going to reconcile offline work here. And hopefully, actually I need to cancel something. I'm going to do one more thing just to be safe. I'm going to get rid of hat switch test entirely from here. Sorry, making decisions on the fly here. I didn't want to take any of the actual show time, so this is all bonus time, so please don't feel cheated if you don't understand what's going on or don't care at all about version control. As I said, I just want to get acclimated to it. So, so we're going to do reconcile offline work now. And choose reconcile, and this is just adding all the files that we hadn't added to the project yet. And then we're going to go to our pending change list, choose submit. That's just in this right click menu, choose submit. And I'm going to write a description, initial check-in for 2D shooter, hit submit. So now all our files are being uploaded to the Amazon cloud, and we'll be able to update them as we go along now, and it will be a lot easier now that we've got the basic setup here done. And so thank you for bearing with me on this. I'm going to try and get this depot set up in some way that you can publicly access it as well, so you'll be able to at least download the files. I want to get something that's a little bit easier for me to update because I've been behind on getting the links to particular episodes going. And so so now we have in our server, we've got all the files that we just worked on. So anyway, as I said, this will make more sense as we use it more. Right now, just bear with me. So I'm going to call that a wrap. And I'm going to switch over to the face. So thank you for joining us tonight. Hope you had a good time. I had a good time. Thank you for bearing with me on the Perforce stuff. As I said, it's going to be an ongoing thing so that people understand what's going on with this. Right now, it doesn't make any sense what I just did there. It's just me. I'm just saving it to a server so that it's safe. That's all that's happening. That's all that I just did right there. And I will explain that functionality better on the show as we continue to work with projects going on into the future. So thanks for joining us. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. You should buy Phil's game, even though he's not here. It's called Robot Alone on iOS. It's $1. It's awesome. And you should... we're taking donations. Again, I'm still behind on actually sending these out, but they will get to you, I swear. It's just I'm slow, and I've been really busy with a lot of things. But there's bonuses. You get a keychain at $5. You get 2 keychains, one signed with a certificate at $10. At $20 in the U.S., you get a Pushy Pixels coaster. At $25 around the world, you get a Pushy Pixels coaster. I have to add the $5 because of shipping. And again, I'm behind on those. Don't expect them soon. If you have a birthday party coming up, it's not going to make it. I'm not making any guarantees as to when this stuff comes in. But I've got lists. I'm getting you guys stuff sent. And thank you very much. And you guys have a great night. All right. And you're welcome for the show. Dan Tower. That's a cool name. All right, so I'm just bantering now, and I'm not going to banter very much because I don't have anyone to banter with. So I'm just running the video so that it doesn't get cut off, because if I quit it early, sometimes YouTube cuts off my video, and I don't like it to cut off the part that I actually care about. I haven't been editing my videos. I'm behind on that. As I said, super duper busy. I haven't been putting the uploaded files available. I'm going to get my backlog done on that for all the previous episodes, and then I'm also going to try and get Perforce set up in such a way that people can publicly access it. And that way it'll be part of the show. You guys will be able to just download stuff as you need it, and I think that'll be more convenient. What else? I mean, that's really it. Thank you guys for joining us, and have a good one.